Bismillahirrahmanirrahim. Students, today we will study the characteristics of enzyme. One thing you already know about enzymes, that enzymes are biological catalysts and they speed up a chemical reaction without being used in the chemical reaction. So here some characteristics are given. First of all, the first character, that enzymes speed up enzyme and speed of the chemical reaction, and you already know that enzymes, they speed up a chemical reaction. Okay, the second character is enzymes are required in minute amount. So as we know that enzymes, they are very important for the completion of reaction, but they are always required in very small or minute amount. Even one molecule of catalase can break down 5 million molecules of hydrogen peroxide just in 1 second. So enzymes, they are required in very small amount. Third very important characteristic of the enzyme which we have to study, and most of the time in Cambridge exam they ask about this character. So that character is that enzymes are specific. So enzymes, they are highly specific in their action. As in the previous video we already discussed that catalases, they always break down or carbohydrates always break down carbohydrates. And proteases always break down proteins. So different enzymes, they work on different or specific substrate. What is substrate? Substrate is the material on which an enzyme is going to work. For example, this one is an enzyme and this one is a substrate. So for their specificity, we have to remember that enzymes, they work just like log and key hypothesis. For example, you already know that always a log is specific and key is also specific to that log. Every key cannot open all the logs. So enzymes are specific, and in the same way their keys are also specific. So for example, here I am giving you an example. For example, I am showing this E as an enzyme. Okay, so this one is, as for example, an enzyme. This site of enzyme where it combined with the substrate is called its active site. So this active site adjusts or it fits a substrate in it. For example, this one is an enzyme, and for example this one is a substrate. Okay, so this substrate will fit here with this enzyme. So what will happen? First of all, these both enzyme and this substrate, they both will combine and they will make enzyme substrate complex. Okay, so this is the active site where it is combining with this substrate and they are making enzyme substrate complex. Okay, in the next step, what is going to happen? This substrate will be broken down. As we were saying that hydrolysis reaction take place. A larger molecule, a larger compound can break down into the smaller one. So what is going to happen here? Enzyme in the end of the reaction will remain the same, unchanged. Nothing is going to happen because we can use an enzyme again and again, and this substrate will break down in its small components or into small products. Okay, so at the end of the reaction the product will form. Okay, this reaction can be, all the reactions can be reversible. You will do study one more character, that as here you can find a larger compound can be broken down into the smaller one. So the case can be reversed. For example, now we can consider this side, that these two small molecules, they are showing substrate, they are going to combine with this enzyme. Now the direction will be reverse. Okay, they will make enzyme substrate complex, and ultimately what will happen? A larger product will form and enzyme will be again remain unchanged. Okay, so in this way the enzyme, they work just like lock and key hypothesis. They are very specific in their action. Okay, for example, amylase is an enzyme which is present in our mouth, in our saliva. It always break down, it always work on carbohydrates. For example, bread, rice, any carbohydrate that will be broken down or that can be converted into its product with the help of this enzyme amylase. Amylase will not work on protein, it will not work on fats, it will just work on carbohydrates, and it will convert it into into smaller parts. For example, sucrose or any other compound can be. Okay. So enzymes are very specific. This is one of the very important characteristic of enzyme. Second most important characteristic of enzyme is that enzymes, they are very sensitive to temperature. Temperature is very important for enzyme activity. Why? We already discussed in the previous lecture that enzymes are protein in nature. Okay, so when a thing is protein, so temperature will affect. You have taken the example, for example, if you have observed in your kitchen that your mother is cooking or boiling an egg, or she is making a fry egg. So what happen when you pour the egg on the hot oil, it quickly cooks. Okay, so it will change its shape. So now you cannot reverse that reaction. So same happen with the enzymes. They are protein in nature. So for example, if temperature is 0, for example, if temperature is 0, so the enzyme activity will be very slow. If we are going to increase the temperature, for every 10 degree centigrade increase in temperature, the enzyme activity will keep on increasing, or you can say that enzyme activity will be double. Okay, for example, here we make a graph of activity, and here is temperature. Okay, now this enzyme will work very slow at low temperature. When we increase the temperature, the rate of activity will keep on increasing until the optimum temperature. What is optimum temperature? Optimum temperature is the temperature at which the enzyme activity will be maximum or best. Mostly this optimum temperature is 40 to 45 degree centigrade. Okay, this enzyme will perform best at this temperature. So at every 10 degree centigrade increase, its rate of reaction will keep on increasing. But after this 40 and 45, okay, so here after a 45, so what will happen? This enzyme will become denature. What is mean by denature? Denature mean this three-dimensional structure of enzyme will become distorted. Remember one thing, in Cambridge we cannot use the word destroy for enzyme. You will never say that enzyme will destroy. No, enzyme will denature. Denature mean its three-dimensional structure. For example, this structure, maybe it change like this after increasing temperature. Now this substrate cannot fit in this enzyme. So what happened? By increasing temperature, three-dimensional structure of enzyme will become distorted. Okay, so enzyme activity will decrease and it will come to 0. And if we decrease the temperature, then this cannot be reversed. Once an enzyme is denature, it is denature for the full time, or it will permanently become denature. Okay, one more very important factor on which enzyme activity is affecting, that is pH. You also read about pH in 7th class, that pH scale you have read that it is to show how acidic or alkaline any chemical or material. So it has range from 1 to 14. If pH of any material is 1, so it's mean it is more acidic. Okay, so as we move from 1 to 14, pH decreases, and here at 7, pH is neutral. For example, this is the pH of water. Water is a neutral compound, and below 7, material are going to be acidic, and after 7, material are going to be alkaline or basic. So second very important character is that enzymes, they are very sensitive to pH. Different enzymes, they work on different pH. For example, we were discussing that when we take food in the mouth, it go into the buccal cavity. So here in the mouth area, first of all, the digestion of carbohydrates starts. In our saliva, amylase is present, which start breaking down these carbohydrates. Okay, and here in the mouth, the pH is 7. Amylase work best on 7 pH. Okay, when food goes here into the stomach, so what happen in the stomach? In stomach, you already know an acid is released that is called hydrochloric acid, and in the stomach pH is 2 to 2.5, and here digestion of protein take place. Okay, this digestion of protein is done by an enzyme which is called pepsin. So pepsin work best on 2 to 2.5 pH. If we'll increase the pH, for example, we increase the pH here in the stomach for the pepsin, for example, to 7 or to 8 or to 9, this enzyme again, it will become denature. Its three-dimensional structure will become distorted. So it will not do any activity, it will not perform its activity, it will not work here then on protein. So enzymes, they are very sensitive to temperature and sensitive to pH. If we increase the temperature or if pH changes, their activity gets affected. Okay, then other thing which is very important in this chapter, okay, we read about the denature and effect of pH. Okay, one more character of enzyme is that if we increase the concentration of enzyme, as we were discussing, that just one molecule of catalases can break down 5 million 5 million hydrogen peroxide molecules into water and oxygen. So if we increase the small amount to a little bit more amount of enzyme, so its activity will further increase. Sometimes it happens if we increase the concentration of substrate, again the activity increases. Okay, one more thing is limiting factor. In different conditions, different factors can act as a limiting factor. What is mean by limiting factor? Limiting factor mean any factor which affects the rate of the reaction. Sometime if we are increasing the temperature, that temperature become limiting factor. Enzyme activity decreases by increasing temperature, or by sometime by decreasing temperature, enzyme's activity affected. So in that case, temperature can be the limiting factor. So any factor which limits, which stop the rate of reaction is called limiting factor. One more character is that enzymes sometime they need coenzyme. Coenzyme can be any metallic part, it can be any vitamin which is the part of that enzyme. So if that enzyme is present, so enzyme activity will be best in that condition, otherwise it will not work properly. And we already have discussed that enzymes, they also catalyze reversible reaction. So these are the characteristics of enzymes. Okay, now you have to do the exercise question. So I will guide you and you will do these questions. First question is, what is an enzyme? And you already know what is an enzyme. You know the definition of enzyme. Then what is a substrate? You already know substrate is a material on which enzyme will act. And then why are enzymes so specific in their action? So we read about lock and key hypothesis. You will explain that lock and key hypothesis in this question. Then the next question is, state the characteristics of enzyme. So you have read all the characteristics of enzyme in today's lecture. So you will write those characteristics, but write briefly. Then why is digestion necessary? In previous lecture, I told you that digestion is necessary to convert large food material into the smaller and soluble and diffusible, so it can absorb in the blood. So it can be utilized, it can release energy. So for that reason, digestion is compulsory. Okay, you will do these 4 questions on your notebooks and you will think about these 2 questions, 5 and 6. In the next video, I will explain these 2 questions. These are related to the pH of the enzyme and temperature of the enzyme. Both are very easy. So you just think about them and then I will discuss and then you will do these questions. Okay, bete, do complete your work, and if there is any problem, you can ask. Thank you, bete.